Hello, good morning. I am Yahya Mohammed Musa, writing from Statistics Department, Nasarawa State University, KP, to present STA122 course titled Laboratory for Inference 1. Is a course that will make use of sample in order to draw conclusion. There is the course content, use of calculator for curve fitting, the goodness of fit, construction of questionnaire and simple index number, use of random number and statistical table. We want to see how we can make use of our calculators. We all know a scientific calculator is more than making use of it in performing simple operations like addition, subtraction, multiplication, and division. Calculator is just a mini device which can contain some functions used to solve arithmetic problem as well as some variable in statistics. When we talk about the curve fitting, is a statistical technique used to derive coefficient value for equation that express the value of the variable, which are the independent and the dependent. Now, this curve fitting is of two types. We have the linear fitting, which involves fitting a straight line of a pair of observations. Then we have the nonlinear fitting, which is in the form of graph, can be in the form of log or exponential. Now, as I've said earlier, calculator is more than performing simple operation. It can be used to obtain mean, variance, standard deviation, and others. Let's see how you can perform, you can obtain your mean using the calculator. For instance, you have an observations, as you can see, if you have an observation, like this, you can make use of calculator in order to obtain your mean, variance, and the standard deviation. Now just follow the steps and you can obtain as listed above. You have step 1. You just click on the mode of the calculator, then followed by number that represent the SD on the calculator. Then go to step 2, enter the data into the calculator and click on M+ button. The M+ button is serving as the memory. In that way, the value will be saved in the calculator. Now, step 3, to check the total number of data saved in the calculator, click on the shifts followed by the number of number that represent n, then equal button. Now, to solve for the sum of x, which is the summation of all the variables, now click on the shift button and then next the sum and the number that represent the x, summation of x in the calculator, then followed by equal sign. Now, so to solve for the mean, just click on the shift, then the x var button followed by the number button, then represents your mean, then equal sign, you get the answer displayed on the calculator. Now, also for the standard deviation, you follow this procedure in step 5 above, then click on the number 2 and then equal sign, and find the variance and so on. Now, apart from mean, standard deviation, and variance, you can also fit a linear regression and correlation using the same scientific calculator. Now, for a given data shows in this particular table, we have n, which is the number of observations, and we have x, and we have y. Now, for you to get your regression using a calculator from this particular table, for example, given, then you can click on the number represent regression. After clicking on your mode, then followed by the regression, then the what type of regression are you looking for? Maybe linear, it will be non-linear. If it is linear, then click on the linear. After clicking on the linear, then go to the next step, enter the data. You first take the first value of x, then followed by comma, and take the corresponding value of y and save using the m plus button. The m plus button, as I've said here, is serving as your memory. We also have step 3. Now, to solve for the coefficient of a linear regression, this simple linear regression, click on the shift button, then click on the value that represented by x bar, and click on the right arrow for display button 3 times, and on 1 and then equal sign, then the result will be displayed. That is for the constants. Also, if step 2, to solve for the coefficient of x, which is b now follow the procedure in this particular step 3 and then click on 2 and equal sign to obtain the result. To solve the correlation, follow the same procedure in step 3, click on number 3 and equal sign to obtain your results. Now, apart from this, quadratic equation can also be solved using calculator. If you are given a quadratic equation of this form, 4x squared minus 7x plus 3 equal to 0, now you can make use of a scientific calculator in order to obtain the given values. Click on mode 3 times, then select equation from your calculator. Scroll to the right from the display button to select the number of degrees that will be used to solve the equation. The degree in this particular example is 2 because the equation is in power of 2. Now, step 2, select the degree. After the degree, then select the number of A, the number of B, and the number of C, which is the constant. A is the coefficient of x squared, while B is the coefficient of x. In this case, our A is 4, our B is minus 7. Then the constant, which is 3. And then followed by the equal sign. Then automatically your answers will be displayed for x1 and x2. That is that about equation. Let's go down to questionnaire. Also, questionnaire is a list of research or survey questions asked from respondents and designed to extract some specific information for research purpose. Now, there are some basic purpose of research questionnaire to collect appropriate data, to make data comparable and amenable to analysis, to minimize bias and format questions. Now, there are some quality of a good questionnaire. This questionnaire has to be brief and limited, simple and clear, and then no personal question is exercised. Now, there are some steps in which you can follow in order to design a good questionnaire. Number 1, decide on the information you required. The type of information you want to get from the respondent. Then define the target respondent. Choose the method of reaching the target respondent is very important. Decide on question contents. Then develop the question wording. Put the question into meaningful format or order. Check the length of the questionnaire. Pre-test the questionnaire before it is used in a full-scale survey. Now, these are some steps in which you can follow to write your questionnaire. Now, this is an example of a sample of a questionnaire. For instance, if you want to test customer satisfaction, maybe a customer comes to your company and bought some customer come to your company and bought product, So you want to test that advisor, you can make it in form of a questionnaire. These are some relevant questions that will be important in the questionnaire. One, were you satisfied with the products? If yes, if no, who did you purchase the product from? Can you recommend us to your family and friends? Will you purchase from our company again? How can we improve your experience for the future? So these are some of the questions in which you'll be expected in designing a questionnaire for customer satisfaction. Now, we also have index number, which is also part of the topic of the particular course. Now, an index number measures the relative change in price and quantity or value of some other item of interest from one time period to another. It has some characteristics. Number one, they are specialized average. They reflect change in level of a phenomenon, measure the effect of change over an interval of time. Now, this index number is useful also in some cases like this. One is the information derived from index number is used for adjustment of salary of government staffs, formulating decision and policy, reveal trend and tendencies. Price index is used to a great extent of wage negotiation. These are some of the characteristics of uses of index number. Now, this index number is of two types. We have price index number, which measure the change in price. Then we have quantity index number. This one study the change in the value of goods produced and consumed in an economy. Now, index number is attached with some of the problems which include data collection. There are cases, issues in terms of collecting data. Then choice of the base period is another problem. Selection of commodity, selection of weight for the construction of index number is another problem. Choice of average, method of combining the data to drive index is another problem. So they are just in a light form. Now, limitation of index number. There are some things that index number cannot do. These include index number only cover part of the field of inquiry. It doesn't cover all part of the field. Weighted factor may become out of date. Doubt of accuracy where sampling is involved. In a case whereby it is only sample you want to deal with, then index number pose a question of accuracy. For no particular year can be called a normal year. It's a some of the limitation. Now, method of constructing index number. We have unweighted method, which includes simple aggregate and simple average of price relative. Then we have weighted, which include weighted aggregate, weighted average of price relative. The simple aggregate method is given by sum of Pi all over sum of P naught multiplied by 100, where our Pi is the total of the current year's price of items or commodity, while sum of P naught is the total of the base year's price of all items or commodity. Whereas the simple average of price relative method is given by sum of P1 over P naught times 100 all over N. Example, let's see how we can compute the price aggregates using this table as given. We have a year of 2000, 2001, 2002, 2003 and 2004, and a given price of a given commodity. I want to calculate each of the price. Want to get the price aggregate. As you can see, for 2000, we want to take 2000 as the base year. In such cases, in all of the years, it will be divided by the price of 2000, which is 120. So if you take the first year 2000, we have P1 all over P naught times 100, which is 120 over 120 multiplied by 100, which is 100. Then taken for the case of 2001, we have 144 as price. So it is 144 all over the base year. This is 120 multiplied by 100, which is 120, which is simply means there is an increase in the price of 120 in 2001. The same case implies that 2002 have 140. That is, there is 40% increase. 2003 will have 70% increase, and 2004 will have 80% increase. Now, this is an exercise for the students. We want to make use of this particular table to construct a price index for the year 1920 to 1924, but in this case we are taking 1922 as our base year. So if you look at our previous example, you can be able to solve this with easiness. Now let's go to the last topic of the course, which is use of random number. We say a random number is generated by a process whose outcome is unpredictable. That's why we call it random. It cannot be predicted, and which cannot be subsequently reliably produced. It is made possible with the help of a random number generator. We make use of this random number generator to generate a random number. Now there are some steps in which you can follow in order to generate the random number. Number one, identify your n unit in the population with the number of 1 to n. Select at random any starting point. Now, number 3, the population unit corresponds to the number of selected in step 2 will constitute the random sample. Now, last, we have statistic table. When we say statistic table, they are tables showing values of cumulative distribution function, probability function, or probability density function of a certain common distribution for different value of their parameters, and they are used especially to determine whether or not a particular statistical result exceeds the required significant level or not. This statistical table will make use of it in hypothesis testing. That is, we compare the results we have in the calculated value with the result we have in the statistical table value, in order to see if we are to reject a given null hypothesis or we are to accept it. Statistical table include, we have the normal distribution table, have the binomial distribution table, have the Poisson, we have the students T distribution table, we have the chi-square distribution table, and also have the F distribution table. These are the distribution table commonly used in statistics for parametric. Thank you so much. Thank you. As we have come to the end of the class, still here, I am Mohammed Musa, Statistical Department, Nasarawa State University. Thank you.